For centuries, humanity has cast its gaze towards the heavens, dreaming of a future where we might soar through the air with the same ease as birds. This enduring fascination found expression in countless myths and stories, but it was the dawn of the 20th century that saw these aspirations take on a distinctly technological edge. The invention of the aeroplane, a triumph of engineering daring, ignited the public imagination, giving rise to visions of a future where personal flight would be commonplace. The concept of the flying car emerged as a potent symbol of this optimistic futurism. No longer constrained by the limitations of roads and railways, people imagined a world of effortless three-dimensional mobility. These airborne vehicles, sleek and futuristic in design, were often depicted zipping between towering skyscrapers or soaring over sprawling metropolises. The allure was undeniable: freedom from traffic congestion, the ability to travel directly to one's destination, and the sheer exhilaration of flight. This dream, however, proved more elusive than initially anticipated. The technical challenges of creating safe, reliable, and affordable flying cars were substantial. Issues of air traffic control, noise pollution, and the sheer complexity of such vehicles posed significant hurdles. As the 20th century progressed, it became increasingly apparent that the flying car, at least in the form envisioned by early futurists, was unlikely to materialize in the near future. Yet the seed of this dream had been sown. While flying cars remained largely confined to the realm of science fiction, the desire for more efficient, sustainable, and interconnected forms of transportation persisted, laying the groundwork for a new wave of futuristic visions. As the limitations of individual flying cars became apparent, a subtle but significant shift began to take shape in futuristic thinking. The focus gradually moved away from isolated solutions for personal transport towards a more holistic vision of interconnected urban environments. This transition was driven in part by a growing awareness of the challenges posed by burgeoning urban populations and the environmental impact of traditional transportation systems. Thinkers and visionaries began to envision cities that were not merely collections of buildings but rather integrated, intelligent ecosystems. The rise of computing power and the nascent internet further fueled these ideas, suggesting a future where data and connectivity could be harnessed to optimize urban living. Instead of focusing solely on how individuals might navigate the skies, the emphasis shifted towards creating intelligent infrastructures that could seamlessly manage the flow of people, goods, and information within the urban fabric. This evolving perspective signaled a move away from the individualistic ethos that often underpinned earlier futuristic dreams. Flying cars, for all their allure, represented a form of personal escapism, a way to transcend the perceived chaos of the city. The emerging vision of smart cities, on the other hand, embraced the complexity of urban environments, seeking to leverage technology to enhance social cohesion, sustainability, and overall quality of life. This shift in focus reflected a growing recognition that the challenges of the future, from climate change to resource scarcity, could not be solved by technological quick fixes alone. Instead, they demanded a more systemic approach that considered the interconnected nature of urban systems. The concept of the smart city has come to embody this new wave of futuristic thinking. It represents a vision where technology is seamlessly integrated into the urban environment, not as an end in itself, but as a means to enhance the lives of citizens. At its core, a smart city utilizes data and connectivity to optimize resource allocation, improve efficiency, and address the challenges of urban living in a more sustainable and citizen-centric manner. Imagine a city where traffic flows smoothly, guided by intelligent systems that adapt to real-time conditions. Sensors embedded in infrastructure monitor air quality, energy consumption, and waste management, providing valuable data that informs decision-making and enables proactive responses to potential issues. Public transportation networks are seamlessly integrated, providing convenient, affordable, and environmentally friendly alternatives to private vehicles. But the vision of a smart city extends beyond mere technological efficiency. It also encompasses the use of technology to foster social inclusion, citizen engagement, and economic opportunity. Imagine digital platforms that connect residents to local services, facilitate community participation in decision-making processes, and provide access to educational and economic resources. The smart city, in its ideal form, represents a convergence of technological innovation and human-centered design, where the power of data and connectivity is harnessed to create more livable, equitable, and sustainable urban environments. It is a testament to the enduring human capacity to dream of a better future and to leverage the tools at our disposal to turn those dreams into reality. The journey from the dream of flying cars to the emergence of smart cities has been marked by a series of technological milestones, each building upon the last and paving the way for a more connected and intelligent future. The invention of the transistor in the mid-20th century stands as a pivotal moment in this trajectory. This tiny electronic switch, a marvel of miniaturization, revolutionized electronics, making possible the development of smaller, faster, and more affordable computers. The subsequent advent of integrated circuits capable of packing thousands of transistors onto a single chip further accelerated this trend, laying the foundation for the digital revolution. The rise of the Internet in the late 20th century marked another watershed moment. By connecting computers across the globe, the Internet created an unprecedented platform for communication, collaboration, and information sharing. It also laid the groundwork for the Internet of Things, IoT, a network of interconnected devices embedded with sensors and software capable of collecting and exchanging data. The IoT forms a cornerstone of the smart city vision. Sensors deployed throughout the urban environment collect vast amounts of data on everything from traffic flow to air quality to energy consumption. This data, processed and analyzed using sophisticated algorithms, provides valuable insights that can be used to optimize city operations, improve resource allocation, and enhance the overall quality of life for residents. From the humble transistor to the interconnected networks of the IoT, each technological advancement has brought us closer to realizing the dream of intelligent, connected cities. While the flying cars of early science fiction may remain elusive, the pursuit of a better future through technological innovation continues, driven by the same spirit of ingenuity and the enduring human desire to create a world that reflects our highest aspirations.